The number of policies that an agent sells is Poisson with modes 2 and 3. K is the smallest number such that the probability of selling more than K policies is less than 25%. Find K. So let X be the number of policies sold, then X has Poisson PMF. And we know that the formula for Poisson is if the mean is m, it's e to the negative m power x over x factorial. So we are given that 2 and 3 are both the modes, which means that f of 2 and the f of 3 are the maximum values of the f, and they're the same because they're both the modes. So actually, the fact that we really need is just the fact that f2 is equal to f3. So instead of mentioning that 2 and 3 are the modes, if they had just said that f of 2 and f of 3 are equal, that's enough information to solve the problem. So mode is a lot more information than we need. Okay, so f of 2 would be e to the negative m power 2 over 2 factorial, and f of 3 e to the okay, should have mentioned that here. So f of 2, okay, I added m to the 2 over 2 factorial, and then f of 3 is e to the negative m cube over 3 factorial. So e to the negative m cancels from both sides, and we bring the 3 factorial on the left, so it's 3 factorial over 2 factorial, and then we move this m square down on the right, so it'd be m cube over m square. So now that is just m, and 3 factorial over 2 factorial is 3. So the mean comes out to be 3. And now we need k, which is the smallest integer, such that the probability of selling more than k policies is less than 25%. So what we'll do is we will tabulate the cumulative probabilities and their complement, because cumulative means less than or equal to x, and the complement would be greater than x. So let me show you the table. So you see, we have x, and then f of x b to the negative 3 power x, since we have found that the mean is 3. So we are substituting 3 in that Poisson formula. And now the cumulative probability is probability of x less than or equal to little x. And for that, you add everything from f of 0 up to f of x. But since the main thing that we are looking for is the probability of selling more than x policies, and we want that probability to be less than 25%. So more than x would be 1 minus less than or equal to x. It's the complement of less than or equal to x, or the complement of the cumulative probability. And once this comes less than 25%, we stop, and we know that this is the least integer for which that's happening. So let's go over the table. So for x equals 0, 1, 2, 3, 4, we substitute those to get these values. And then the cumulative f of 0 is at 0, it's just 0. At 1, you add the 0 and the 1. And then at 2, you add the 0, 1, 2 to get that. And then so on. And then the x greater than x will just be the complement of this column. So we see that until x is, so for x equals 0, 1, 2, 3, the probability of selling more than x policies is still higher than 25%, because this is 36%, that's 57%. But once we hit x equals 4, this is saying that the probability of selling more than 4 policies is 18.47%. So now that's the first time that more policies probability has dropped below 25%. And that was the question. The question was to find the smallest integer k such that the probability of selling more than k policies is less than 24%. So even though for all other integers, if we keep going in this table for 5, 6, 7, 8, and so on, it will keep getting smaller and smaller, and so it will always be less than 25%. But this is the smallest integer for which it's dropped below 25% for the first time. So k is 4, and that was choice D.